It's up now. We're good to go.
Got it. All right, we are good. Okay, memory allocation. This is part of my, again, I hate to keep plugging. I don't hate to keep plugging the book. I'll keep plugging the book. As I explore different pieces of Win32Forth, I begin to use them. And I had never used memory allocation before. It's a part of the ANS standard, but now I get competent in it. So the current ways that Forth allocates memory is that the most common way is that you can extend the dictionary with some reserved space by here. So you would put a lot to add extra space. Things like C comma will add a character, comma will add an integer value, F comma will add a floating point, and so on. And then within variables and values, you can store numbers, and you can do an array with something like create and then reserve a lot of space. But these are all fairly restricted because the allocation is in the middle of the dictionary. And if you overrun the storage, you run the risk of damaging words that are subsequent to your storage. So an isolated memory is great. So if you need more memory, the typical uses might be if you're doing matrices, large manipulations externally, you're adding a database, you want to bring in a file buffer, places where you would need a couple thousand to a megabyte or so of memory. So the American National Standards provided 3 very powerful words. They allocate, free, resize, and memory allocate. At the bottom, memory, ALLOC, is a constant that is in the environmental vocabulary, and it will just tell you yes or no, you have support for memory allocation. If it comes back false, you do not have memory allocation aboard the system. So once you've established that you do have memory allocation, then the words allocate, free, and resize are the utilities. Allocate, you give it a byte request, and it will return the address of the allocation and a flag. The flag is inverse from what you might think. If there has been an error, you get a true flag. And the reason for this is that this feeds directly into catch and throw. So you use a true flag upon an error, and then throw will pass an error number back to the upper levels of the system for error recovery. Free does the same thing. In case free, you give it the address of your allocation, and it will return a flag. Was that allocation done, or the return of allocation done properly? I'll note here that the indicator or the identity or the call file ID of that allocation space is its Forth address. So you need to preserve that Forth address and in general give it a name for future manipulation. And finally, with resize, just what you'd expect. If you give it the address of your allocation and execute resize, it will then give you the U is the unsigned value of the number of bytes you're requesting for the new size. Then you'll get back the address to value, which is the new allocation and a flag on successful execution. Now, Win32Forth has taken that into or assumed those words and simplified them where the error check is already built in. So allocate, MALLOC, does the same thing as allocate, but it will automatically give the throw an error if there's an error flag. So these would go into your applications unless you want to do your own specific error recovery. Release, same way, it will release the allocation, and reallocate will change the allocation size. It's my observation that reallocate, if the allocation is larger than your first allocation, the contents will be copied across. For a reallocation, if the new allocation is smaller, it will still be copied across, but it appears to copy the entire contents. And so I'm not quite sure what happens with the content that is beyond the requested size. That's kind of a question mark. Here's an example of the usage. I do 1024 allocate, which gives me the address and the flag value back for an allocation. The -271 is an allocation error. It's a built-in text string that says allocation error. And then question throw checks the flag, which is second on the stack, and then applies that -271 if necessary. The question throw is kind of clever because the error flag is second on the stack, and so the question throw looks second on the stack for is an error occurred or not. After that error flag has been processed, then a value is created, and it's named memblock1. So that will now contain that is now the name of our allocation. And then .mallocs shows the allocation, which I have reprinted down below. And you see that at the beginning of the memory allocation block or a record there you can see 1024. This memallocs shows you allocations that are used within the running fourth itself. So that list is about 10 items on that list. So here's an example of usage. I created text one, and then with the comma quote, put a simple counted string into that space, sample text for allocation. Then with text one, we reference that string. Memblock1 gives us our memory storage area. Text one count 1 plus nip calculates the text size to be moved. So we're moving from text one to memblock1 done by the C move. It's a little diagnostic writing line on the command line. We give a comment that said we stored, and then it prints out what the allocation contains. So below that in black, we see the output, which says we stored, and then sample text for allocation, which is exactly what was in text one. So the allocation is there. I just wrote a word to combine it all for a reallocation. In this case, we're changing the allocation to 2048 bytes, and we do the same reallocation with the same error code. And now that is passed back to the value memblock1. So now memblock1 holds the name of the new allocation, which is 2048 large. Mallocs again shows us the allocation table, and then memblock count type displays the contents. And let's see how we got. Sure enough, the allocation table now has 2048 bytes in it, and the output came out of sample text for allocation, did a copy over, and that is demonstrates our text got into the new buffer. Finally, we do a free. In this case, we just give it the block allocation name number. And notice down now in the allocation table, the 2048 has disappeared. So we leave the system clean. My conclusions were that first, this process was much more straightforward than I had originally thought. The file allocation is a little more complicated. There's several steps to it, but memory allocation is quite straightforward. You request the allocation and you get it. As we saw, Win32Forth has several words which simplify the ANS words for ease of programming. And then in conclusion, I now like these allocation words. It's joined my usage of catch, throw, and locals, which I have learned to understand and love in the last few months. So that concludes my remarks, and we're back to home base. So thank you very much for your attention. All I ask for is a 20-minute head start.
You have nothing but our gratitude, Phil, and I'm really looking forward to the opportunity to buy the paper hard copy book.
Let me interject a little thing on the book, because I've scratched my head on this a bunch of times, and here is the proposed release to whet your appetite. There will be a hard copy published in hardcover with color content in hardcover, and I'm guessing it'll be about $35. That's essentially selling at cost on Amazon, but I will also have the identical system available as a PDF on GitHub. So the request, instead of putting a CD in the back of the book, which is impossible, what it means is anybody who gets the book can go to my GitHub page and get a PDF version because it has hot links in it. So from the table of contents and from all the references inside, you'll have hot live links. So I suspect devoted people will buy the hard copy for sitting around the fire in the evening with their smoking jacket on and their easy chair to read for recreation. And then when they're at the keyboard, they would get the PDF version. Thank you.
Is this going to be a print to order on Amazon, or is it going to be actual publication run?
The process I use is print to order on Amazon with a 2 to 3 week lead time, mostly like 3 weeks. But I'll also have it on eBay, and the value on eBay is you get a signed copy. Same books.
Ooh, I'm going to go for that. That's awesome.
Well, it's really good because on the Amazon copy, I make about $1.80, and on the eBay copy, I make about $4. So I much prefer eBay. As you can see, this is labor of love. This is not for financial reward.
Let me comment about memory allocation and everything. One of the things is I was just looking at is essentially built into the MALLOT by Ron and all, and I don't. I use it. I mean, in what I just did, it was used hundreds of times. But one of the things, major difference probably in speed between Cozy and K, which is very, it's one of the fastest systems in the world. Is that
Bob? I'm afraid I'm going to have to pull plug on.
In case
we're really in a time bind.
It needs to be done.
I'm sorry.
Forth.
Thank you, Bob.